Hello, bedtime thinkers, and welcome to the Bedtime Discoveries. I'm so glad you're here tonight. This is your time to slow down, to breathe gently, and to drift into the comfort of science told softly. Tonight, we will wander through the quiet mystery of the forest. We will explore a question that has fascinated scientists and dreamers alike. Do trees truly communicate? Though they seem silent, still, and rooted, trees may whisper in ways our human senses cannot hear. Together, let us uncover the gentle secrets of how trees may speak to one another. Before we begin this journey, I'd love to know where you are listening from. Would you softly share in the comments your location and the time it is for you right now? It always warms my heart to see this little community, connected across time zones, across countries, much like a forest of listeners quietly linked together. And if you enjoy these quiet explorations, please consider pressing the like button and gently subscribing to the Bedtime Discoveries, so you'll never miss a chance to fall asleep with science. Imagine yourself walking slowly into a forest at dusk. The air feels cooler here, softer, filled with the earthy scent of soil and moss. Above you, tall trees stand like ancient guardians, their trunks rising upward, straight and patient, their branches stretching wide, as though holding the sky itself. At first, it feels silent, a kind of silence you don't often hear in busy cities. No car horns, no rushing footsteps, only the faint rustle of a leaf falling, the occasional call of a distant bird, or the soft hum of a hidden insect. It's easy to believe that the forest is asleep, that trees simply stand, unmoving, unthinking, living statues, waiting for wind and rain. But science has revealed that this silence is only an illusion. The forest is not silent at all. It is alive with messages, exchanges that flow invisibly beyond our hearing, a language written not in words, but in scents, in signals, and in secret vibrations. Think of the forest as a great library, every tree a book, every root a thread binding the pages together. But unlike a library where people whisper in human voices, this library of trees whispers in ways more ancient, more delicate, and infinitely more patient. The silence, then, is not empty. It is full of things unseen, like letters drifting through the soil, like invisible ink carried by the breeze. For thousands of years, people stood among these trees, never suspecting their quiet conversations. We saw them as background, as scenery for our own lives. But slowly, through the lens of science, we began to hear the whispers hidden in the stillness. And so, when you next step into a forest, and it seems silent, remember it is not. It is speaking in its own way, patiently, gently, and always connected. Picture yourself lying back on soft forest ground, eyes half closed, watching sunlight filter down in golden beams. Each leaf catches the light differently, a shifting mosaic of green and gold. It seems calm, still, but under that calmness, a slow and steady rhythm pulses. Scientists once believed that trees were passive, simply standing, waiting for sun and rain. Yet in the last few decades, new discoveries have overturned that belief. The forest is busy when a tree stretches its roots deeper into the earth. It is not only drinking water, it may be reaching toward a neighbor's roots, brushing against them, exchanging tiny signals of recognition. When a breeze brushes through branches and a tree bends ever so slightly, it sends minute vibrations through its wood and its leaves. Some scientists believe these vibrations can be felt by nearby plants. Tiny tremors in the language of the forest, Even the so-called silence of night is filled with activity. Roots continue to grow in the dark. Sap rises slowly in the trunk, and chemicals drift unseen through the air. Whispered warnings, whispered reassurances. The quiet is not the absence of sound. It is a slower sound, a rhythm too patient for our hurried ears. If you could speed up time, you would hear branches creak like voices, roots stretching like murmured words, leaves unfurling with soft sighs. This illusion of silence is perhaps one of nature's greatest disguises. It teaches us patience, that not all communication is fast, loud, or obvious. Sometimes the deepest conversations are the ones carried out slowly in the background, over hours, days, or even centuries. And as you lie there, imagining the trees around you, it becomes easier to sense that they are not silent at all. They are simply speaking in their own time, a time so different from ours that it feels like quiet. Let me share with you a story about a researcher walking through an old-growth forest in Canada. Her name was Suzanne Samar, and while others saw trees as individuals, she began to notice patterns of connection. She discovered that beneath the forest floor, trees were passing carbon, nitrogen, and messages through a vast underground web. What looked like silence was in fact a living conversation. In one experiment, a tree shaded from sunlight was found to be receiving sugars from its neighbors. Sugars passed not through the air, but through the soil, through an invisible network. It was as though the forest had decided, this one must not fall. We will help. Another story comes from Africa, where acacia trees, when grazed heavily by giraffes, release chemicals into the air, warning nearby acacias to fill their leaves with bitter toxins. The giraffes, clever as they are, must then wander further, for the forest has quietly warned its members. And in Germany, in ancient beech forests, scientists discovered that old trees would slow their own growth, so that young saplings in deep shade could have a chance at survival. What appears to us as silent trunks standing in stillness is, in reality, a society, cooperative, caring, and deeply connected. These stories remind us that silence can be deceiving. The forest may not speak with voices we recognize, but it speaks nonetheless, with patience, with kindness, with signals carried in roots and air. So, the next time you enter a forest, close your eyes, breathe in, feel the hush around you, and remember, you are not standing in silence. You are standing in the middle of a great, ancient conversation. Imagine standing in the middle of a forest once again. Your eyes see only what is above ground, the trunks, the branches, the leaves, but what you cannot see is often far more vast. Beneath your feet, just below the layer of soil and moss, lies an entire hidden world. A city of roots stretching outward, twisting, winding, and connecting. For every branch that reaches toward the sky, there is often a root stretching downward or outward, mirroring its form, yet unseen. Roots are more than anchors. They are explorers, reaching through soil in search of water, minerals, and stability. But as they grow, they often meet the roots of other trees. Sometimes they touch gently. Sometimes they fuse together. Sometimes they form long-lasting bonds where the tissue of one tree merges with the tissue of another. It is almost like the underground handshake of neighbors, a greeting, a joining, a recognition. For centuries, humans believed roots were simply selfish structures, working only for the individual tree. But as science has looked closer, with careful studies, with slow patience, it has revealed something surprising. Roots are not only tools for survival, they are bridges, they are messengers, they are threads in a tapestry that binds a forest into a single living network. If you close your eyes now and imagine the soil beneath you becoming transparent, you might see them stretching like rivers underground, touching, twining, and forming pathways of life. A secret world right beneath your feet. When one tree's roots connect to another's, something remarkable happens. A flow begins. Sugars created in the sunlight by one tree can move toward another tree that stands in shade. Water absorbed by a tree near a stream can flow toward a tree growing on drier ground. It is as though the forest has designed its own quiet redistribution, ensuring that no tree suffers alone. Sometimes scientists have found that entire groves of trees may share roots so thoroughly that what looks like many trees is in fact one organism, connected by a single vast root system. A famous example lies in Utah, a forest called Pando, the Trembling Giant. It is a grove of aspen trees, 47,000 stems above ground, but all connected below by one immense root network. By some estimates, this living system is nearly 80,000 years old, making it among the oldest known organisms on Earth. Imagine that for a moment, walking among those aspens, believing you are surrounded by tens of thousands of trees. Yet in truth, you are inside the body of one vast living being, one root system, one heartbeat, quietly persisting for millennia. Even outside of Pando, the principle is the same. Roots connect, they share, and they allow the forest to function not as a crowd of individuals, but as a family, as a community, as a single breathing, interconnected whole. When we walk in a forest, we see trunks standing apart, but below they are holding hands. Let me tell you a story of survival, of how roots may mean the difference between life and death. In Germany, researchers once stumbled upon a stump. The stump was moss-covered, ancient, with no leaves, no branches. By all appearances, it should have been dead long ago, and yet, when they studied it, they found that sap was still flowing inside it. Life was still present within the hollow body. How could this be? The answer lay in the roots. Neighboring trees had connected to the stump and were feeding it sugars, water, and minerals, keeping it alive century after century. Why? We do not fully know. Perhaps the old tree had once shaded them. Perhaps it had once shared with them. Or perhaps the forest simply does not abandon its own. Another story comes from areas struck by drought. When certain trees lose access to water, they can still receive it from neighbors through root connections. These lifelines allow the forest to endure together, where isolated individuals might wither. Even in the winds of a storm, roots prove their unity. When gale force winds blow across a hillside, trees that stand alone are far more likely to fall. But trees whose roots are interwoven with others support one another, bracing against the force. Like a crowd of friends linking arms against the wind, they survive together. So, when you see a single tree, remember that it is never truly alone. Beneath the soil, it may be holding on to countless others, connected in ways we are only beginning to understand. The root network, invisible to us, is the forest lifeline. It is the quiet reminder that strength lies not only in standing tall, but in being deeply connected. Close your eyes for a moment and imagine the soil beneath a great forest. You might picture it as a simple layer of dirt, rocks, and roots. But in truth, it is far richer, far more alive than most people realize. Beneath the soil runs an invisible web. Not the web of spiders, not the web of silk, but the web of fungi. Tiny threads, called hyphae, finer than a human hair, stretch and twist through the darkness, reaching across vast distances. These threads form vast networks. So vast, in fact, that some scientists believe fungi may be the largest living beings on Earth. In Oregon, one single fungal network spreads underground for over 2,000 acres and is thought to be thousands of years old. Imagine that, a single being quietly threading its way beneath a forest, watching centuries pass, while humans come and go. But what makes these threads even more remarkable is how they intertwine with trees. Fungi form intimate partnerships with roots, wrapping around them, piercing into them, becoming part of them. This partnership is called mycorrhiza, from the Greek words for fungus and root. It is through this connection that fungi create the highways of the forest. Highways not of stone or steel, but of microscopic threads, carrying signals and supplies from tree to tree. The forest beneath us is crisscrossed with these fungal pathways, like invisible roads in a hidden city, always active, always alive, while we walk above, unaware. Scientists sometimes call the system the Wide Web, and it is not a metaphor made in haste. For much like the internet connects humans across vast distances, fungal networks connect trees across entire forests. Picture this. A tall pine catches sunlight in abundance, its needles brimming with sugars from photosynthesis. But nearby, in the shadow of its branches, a young sapling struggles, unable to reach the light. Through the fungal network, the pine can send some of its sugars downward into its roots. The fungus accepts these sugars as food, and in return, carries some of them across its tiny threads, delivering them to the shaded sapling. It is as though the fungus is a postal service, carrying little packets of nourishment from one tree to another. But it does not stop with food. Nutrients like nitrogen and phosphorus also travel through these threads. Even warning signals, electrical pulses, chemical alerts can pass from one tree to its neighbors through the fungal highways. A tree under attack by pests may send out an alarm through this underground system. Nearby trees receiving the message can begin to prepare their defenses, producing chemicals to make their leaves less tasty, long before the pests even arrive. The fungus itself benefits too. In exchange for its services, it receives steady streams of sugar from the trees. This mutual aid has been at the heart of forests for hundreds of millions of years. So when you walk into a woodland, you are not stepping into a collection of isolated trees. You are stepping into a society linked by invisible highways, a quiet, hidden internet, where every tree is a node and every fungus a messenger. Let us look deeper still, for fungal highways are not only about exchange. They are about balance, about wisdom, about the survival of the whole. In some studies, scientists found that fungi seem to favor certain trees. They may send more resources to young saplings or to sick individuals that need help. It is almost as if the fungal web makes decisions, like a wise caretaker, choosing where aid should flow. There are even stories that sound almost unbelievable. For example, in a mixed forest, some trees of one species have been found to send carbon through fungi to completely different species nearby. Imagine an oak tree feeding a birch, or a pine supporting a beech, all because the fungal threads carry resources where they're most needed. And beyond the realm of food and water, there are whispers of sound-like communication. Some researchers suggest that hyphae can carry tiny electrical pulses similar to nerve signals in animals. These pulses may be how warnings and messages are sent quickly from one side of a forest to another. It is as though deep beneath the soil, there's a whispering voice passing from fungus to root, root to fungus, tree to tree, a voice we cannot hear, but one that has guided forests for millions of years. Think of the beauty of this. Above ground, we see trees competing for light, branches spreading, each seeking space. But underground, through fungal highways, those same trees are cooperating, sharing, balancing, sustaining one another. The forest, then, is not a battlefield. It is a conversation. It is a community. It is a society of roots and fungi, where the needs of the whole outweigh the needs of the one. And perhaps that is the deepest lesson of fungal highways, that survival is not about standing alone, but about being connected. That wisdom is not shouted, but whispered through threads of patience and care. So next time you walk through a forest, pause for a moment, breathe deeply, and imagine beneath your feet a vast and silent highway system, threads stretching outward in every direction, carrying food, water, warnings, and whispers, the hidden pulse of the earth, the quiet web, the fungal highways that keep the forest alive. Imagine the forest again. Sunlight trickles through leaves, dappling the ground in shifting patterns of gold and green. Each tree drinks in that sunlight, turning it into sugar through photosynthesis, a quiet miracle happening in every leaf. But not every tree is blessed with equal light. Some stand tall, their crowns high above, bathing in sunshine. Others, young or shaded, live in dimness, their leaves straining for just a flicker of brightness. If life were only about competition, these shaded trees would wither and fade. And yet they do not, because beneath the soil, something extraordinary happens. The sugars made in sunlit leaves do not always stay with the tree that made them. Through roots and fungal highways, they travel outward, shared, given, gifted to neighbors who need them. Scientists once thought this idea impossible. Why would one tree give away its hard-earned food? Why would it not keep everything for itself? But experiment after experiment has shown that forests do indeed share. A tree in sunlight may send sugars to one in shade, balancing survival across the whole community. This is not charity in the human sense. It is a deep evolutionary wisdom. For in helping neighbors survive, the forest ensures its own survival too. Picture a tall mother beech, its branches thick with leaves, shimmering in the wind. Beneath her, small saplings tremble in the shadow, unable to reach the sun. Yet through the roots, the great mother passes some of her sugar downward, keeping her children alive until they can grow tall. The forest is not selfish. It is generous. It gives so that life continues. To understand how trees share nutrients, scientists have traced their pathways with delicate experiments. In one study, researchers used a special form of carbon dioxide, tagged so it could be detected. They allowed a tree in bright sunlight to breathe it in, turning it into sugars. Later, they looked at the roots of shaded trees nearby, and there was the same carbon, the same sugars, now inside those neighbors. The forest had shared. This sharing can happen in many directions. Nitrogen, phosphorus, and other minerals can flow as well, from where they are abundant to where they are scarce. Sometimes the transfers are small, a tiny helping hand, like passing a sip of water. Other times, they are significant, enough to mean the difference between life and death for a sapling. Think about this. In times of stress, drought, poor soil, storms, trees that are well-rooted and strong may give more to those in need. And later, when the roles are reversed, the favor can be returned. This balance is not a one-time gift. It is an ongoing exchange, a quiet economy of life beneath the soil. But unlike human economies, it is not driven by greed or profit. It is driven by the survival of the whole. Consider again the Pando Aspen Grove in Utah. 47,000 trees, but all one organism. When one part Pando thrives, the whole thrives. When one part suffers, the whole suffers. So naturally, resources move to where they are needed most. The same principle applies in forests around the world. Even when trees are of different species, they can share. Through fungal highways, a birch can give carbon to a fir, or a fir can send nitrogen to a birch. Rivals above ground, but partners below. It is a vision of life that is both humbling and inspiring. Competition above, cooperation below, balance, always balance. Let me tell you a story from Canada, where researcher Suzanne Samar carried out a now-famous experiment. She studied Douglas firs and paper birches growing together. In summer, when birches had broad green leaves, they made plenty of sugar. Some of that sugar traveled underground through fungal networks into the roots of the firs. The firs, shaded by the birch's leaves, received a vital boost. But in autumn, the balance shifted. The birches began to lose their leaves, while the evergreen firs still held on to their needles, making sugars. And in that season, the firs gave back. Sugars flowed the other way, from fir to birch. It was a partnership, not a rivalry. Each supported the other when the time was right. Another story comes from the African savanna, where umbrella thorn trees grow in scattered groups. In dry years, trees near riverbeds take in more water than those on dry ridges. And through underground connections, water moves quietly, invisibly, from the lucky to the thirsty. It is as if the forest whispers no one should go without. Even in extreme places, deserts, tundras, high mountains, plants that share nutrients often survive longer than those that do not. It is a universal language of generosity. And what the old stumps, the ones with no leaves, no sunlight? As we saw before, some stumps live on for centuries, kept alive by neighbors. They no longer give, but they are not cut off. The forest keeps them in the circle, perhaps honoring the role they once played, perhaps remembering that all life is connected. So when you stand among trees, know that beneath you flows a quiet generosity. Sugars, minerals, and water move unseen, carrying life from one being to another. The lesson of the forest is simple. Strength is not only in what we keep for ourselves, but in what we share. The forest thrives, not because every tree is strong, but because every tree is connected. Imagine walking into a sunlit meadow at the forest's edge. You see tall acacia trees standing in the warm light, their leaves shimmering gently in the breeze. To the human eye, they seem peaceful, untroubled, simply swaying. But suppose a giraffe comes to graze, stretching its long neck, pulling leaf after leaf into its mouth. To us, it is a natural, quiet scene. Yet inside the acacia, something extraordinary is happening. The tree senses the wound, the tug of leaves being torn away, and within moments, it begins to release chemicals into the air, invisible to us but powerful to other trees. Nearby acacias smell these chemicals on the breeze. It is as though the first tree has sent out a warning. Beware, danger is near. The neighboring trees respond swiftly. They begin to flood their leaves with bitter-tasting tannins, making themselves less appealing to hungry mouths. Some even produce toxins strong enough to make animals sick if they eat too much. The giraffes, clever and observant, notice this change. They move along, searching for trees further away, and the forest has protected itself, not by noise or battle, but by whispering warnings carried invisibly on the wind. This is one of nature's hidden alarm systems. Trees, though rooted and still, are never helpless. They sense, they warn, and they adapt in ways that are both subtle and astonishing. The forest, though silent to us, is alive with alerts. How exactly do trees send these warnings? The process is complex, but also elegant. When leaves are damaged by insects, by grazing animals, by disease, the tree's cells release special chemicals known as volatile organic compounds. These compounds drift into the air, carried by even the slightest wind. Other trees nearby detect them through receptors in their own leaves and immediately begin to prepare their defenses. It is almost as if the air itself becomes a language, a flowing script of invisible letters, where every molecule is a word, a phrase, a warning. Scientists have tested this in carefully designed experiments. They place plants in sealed chambers, with airflow directed from one plant to another. When the first plant was attacked by caterpillars, the second plant, untouched by insects, began producing defensive chemicals, simply because it received the airborne signal. This shows us that communication between plants is not imagination. It is real, measurable, and deeply effective. But trees do not only warn through the air, they also warn through their underground networks. When one tree is wounded, it can send electrical signals down into its roots. Through fungal highways, those signals travel to neighbors, and the neighbors begin preparing for the same attack. Think of it as a fire alarm system in a building. One detector senses smoke, and soon alarms ring throughout the entire floor. No tree stands alone in the face of danger. Even more astonishing, some studies suggest that these signals can be species-specific. That is, a pine may send one kind of message, while an oak sends another. The forest is filled with overlapping languages, each tree fluent in the dialect of its neighbors. And yet, across all these languages, the meaning is the same. Be ready, danger is near. Let me share with you a story from the African savanna again. Researchers noticed that giraffes did not feed randomly on acacia trees. Instead, they would graze a tree, then walk some distance, often more than 100 meters, before feeding on another. Why? Because acacias downwind from a grazed tree quickly filled their leaves with bitter tannins. The giraffes, aware of this invisible conversation, avoided the newly defended trees. The forest had warned itself, and the giraffes had learned to listen. Another story comes from North America. Poplar and willow trees, when attacked by insects, release airborne signals that nearby plants detect. These neighbors then produce chemicals that make them less digestible, and sometimes even release compounds that attract predators of the insects. Imagine that, a tree under attack, sending not only a warning to its neighbors, but also a call for allies, tiny wasps or beetles, to come and chase the attackers away. In Europe, researchers studied young tomato plants. when one was damaged, it released signals that traveled to others. The undamaged plants began producing anti-insect chemicals. The result? When caterpillars were introduced, they ate less, grew slower, and struggled to survive, all because the plants had listened to a silent warning. Even underwater plants, seagrasses, appear to send signals through water currents. When grazed, they release chemicals that drift like invisible ink through the sea, alerting neighbors to strengthen their defenses. What we see again and again is that warning signals are universal, whether in forests, savannas, meadows, or seas. Plants do not face threats alone. They speak, they warn, they prepare together. The lesson is simple, yet profound. The forest teaches us that even in stillness, there is awareness. Even without voices, there is communication. And even in silence, there is strength. So the next time you walk among trees, pause for a moment. Listen not with your ears, but with your imagination. For though you cannot hear them, the trees are whispering. They are vigilant. They are watching over one another. And perhaps, in their quiet vigilance, they are also watching over us. When you step into an ancient forest, look around carefully, and you will notice that not all trees are the same. Some are slender, young, and reaching upward for light, while others are enormous, their trunks wide, their branches stretching like arms to the sky. These giants are the elders, the ones who have stood through centuries of storms, felt countless seasons pass, and witnessed the slow rhythm of forest life. Scientists have come to call these giants mother trees. It is not just poetry, it is science. For these older, larger trees play a central role in caring for the forest around them. Mother trees send nutrients through their vast root networks, sharing food with smaller saplings that struggle to reach sunlight. They create shaded spaces where tender shoots can grow without burning in the sun. And through fungal highways, they pass along carbon, nitrogen, and other life-giving elements to those who need them most. The young trees that grow near a mother tree are more likely to survive. They are more resilient during droughts. They are stronger against disease, and they grow with a kind of quiet guidance. It is as though the forest itself recognizes the wisdom of age and allows its elders to nurture the next generation. In many indigenous cultures, there has long been a belief that the forest is a family. The biggest trees are like grandparents, protecting and guiding the little ones. Now, science is beginning to confirm what ancient wisdom has always known. A mother tree is more than wood and leaves. She is a guardian, a provider, and perhaps in her own silent way, a teacher. The discovery of mother trees comes largely from the work of forest ecologist Suzanne Samar in Canada. She spent decades studying how trees interact below the ground, and what she found was extraordinary. Using carbon isotopes, a kind of scientific tracer, she could follow the flow of nutrients from one tree to another. Her experiments revealed that large, old trees were not only absorbing carbon through photosynthesis, they were actively sending some of it into their roots, and then sharing it with younger, smaller neighbors. This sharing was not random. It often followed the lines of kinship. Saplings grown from a mother tree's own seeds received more carbon and nutrients than strangers did. It was as though the mother tree recognized her offspring and gave him a stronger helping hand. But the generosity did not stop with her own children. Mother trees also supported weaker members of the forest, helping them to survive during difficult times. In droughts, for example, nutrients and water could move from the stronger trees, to those that were wilting. Electrical signals also traveled along root and fungal networks, allowing mother trees to send alerts of danger. If one tree was attacked by insects or disease, its signals could spread through the fungal threads, and neighbors, guided by the elder, would begin to fortify their defenses. This paints a picture of the forest not as individual trees, but as a community bound together, with its leaders quietly shaping the survival of all. Mother trees are also biodiversity anchors. Because of their immense size, they provide shelter for countless creatures. Birds nest in their branches. Owls find hollows in their trunks. Insects make homes in their bark. Even when they eventually fall, their logs become nurseries for mosses, fungi, and the next generation of saplings. In every stage of life, from standing tall to lying still, a mother tree gives. She nourishes the forest even in death. Let us imagine for a moment a great Douglas fir in the forests of British Columbia. She is 300 years old, her roots stretching wide beneath the soil, her crown towering above all others. Nearby, a young fir struggles in her shade. It cannot reach the sunlight, and without help it may wither. But through the underground fungal web, the mother tree sends carbon and nitrogen, just enough to keep the sapling alive. Slowly, season after season, the little tree grows stronger. One day, when the old giant finally falls, the young tree will be ready to rise, carrying the forest into the future. This story is not just imagination. It is what research has shown again and again. Forests endure because their elders give freely. Another example comes from birch and fir trees. In one study, scientists found that when firs were shaded and weak, birches sent them carbon to survive. Later in the season, when the birches lost their leaves, the firs returned the favor, sharing carbon back with the birches. But it was the largest, oldest trees that coordinated the majority of these exchanges. The wisdom of the mother tree lies not only in her size, but in her patience, her ability to see beyond herself, to keep the community alive. In ancient human stories, elders were the keepers of knowledge, passing down wisdom to the young. In the forest, mother trees are the same. They hold memory in their rings, knowledge in their roots, and life in their branches. And when you walk among them, you can almost feel that presence, a calm, quiet strength, a reminder that even in silence, there is love. The forest teaches us something profound through its mothers. That survival is not just about competition, but about care, generosity, and connection. So the next time you rest against the trunk of a great tree, perhaps pause, close your eyes, and imagine the web of life beneath your feet. The mother tree is there, watching, nurturing, giving, and she has been doing so for centuries. If you stand quietly in a forest, close your eyes, and simply breathe, you may think the trees are silent. But silence, in this case, is only an illusion. In truth, the forest speaks in many voices. Some are carried on the wind. Some are whispered underground. Some are hidden in the way leaves and roots change their chemistry. These are not voices like ours, not sounds in the air, not words shaped by tongues, but their languages all the same. Imagine a great oak tree. When insects chew at its leaves, the oak releases airborne signals, tiny, invisible chemicals that float away. Nearby oaks detect the scent, understand its meaning, and begin to strengthen their defenses. This is one language. A chemical language carried by the breeze. Now imagine a pine tree in winter, beneath the frozen ground. Its roots are still connected to others through a vast fungal web. Here, sugars, water, and signals pass like messages down a telephone line. This is another language, a language of roots and threads, spoken in the dark and quiet earth. But there's still more. Some trees communicate through subtle changes in their vibrations. When drought dries the soil, air bubbles form in the tree's water channels, and the resulting tiny pops, ultrasonic sounds, may be detected by neighboring plants. This is yet another language, silent to our ears, but real in the forest world. So when we say, trees talk, we must imagine not one voice, but many, a chorus of languages, each adapted to a need, each carrying meaning across space and time. And just as humans speak differently with children, friends, or strangers, so too do trees adjust their signals depending on who is listening. The forest is not a single story, but a library of conversations. Let us look more closely at these languages. The chemical language of trees is perhaps the best studied. Volatile organic compounds, tiny molecules like jasmonic acid, methyl salicylate, and terpenes, float invisibly through the air. Each compound carries a specific meaning. Some warn of insect attacks. Others attract predators to come and feed on those insects, while still others prepare tissues for drought or frost. It is almost as though trees write letters on the wind, each with its own fragrance, each with its own urgent message. Then there is the electrical language. When roots sense injury or stress, they can generate pulses of electrical energy, tiny currents that flow through tissues, and sometimes across fungal connections to neighbors. These signals can move faster than chemicals, like a spark racing down a wire, alerting the network that something is wrong. Imagine one tree struck by lightning. The wound is deep, the bark split, but before the damage spreads, its roots fire off electrical alerts. Nearby trees begin shifting their internal chemistry, readying themselves for possible stress. This is a silent alarm, a flash of communication beneath our feet. And then there is the vibrational language. Trees draw water upward through narrow channels in their trunks. When conditions are normal, the flow is smooth and steady. But when drought strikes, tiny cavitation bubbles pop inside these channels, creating ultrasonic clicks. Researchers have recorded these sounds, inaudible to human ears, but possibly detectable by other plants. It is as though a thirsty tree is whispering, "I am in need, be ready." Together, these languages form a web of meaning, chemical, electrical, vibrational, each suited to a different kind of message, each weaving together the fabric of the forest communication. The most enchanting part of these languages is how varied they are, just as human cultures have many dialects. Trees, too, have different ways of speaking. Take acacias in Africa. Their warning gas, ethylene, is a sharp, rapid message, ideal for the open savanna, where winds carry signals far and wide. Contrast that with beeches or firs in European forests. Their root-based exchanges, flowing through fungal threads, are slower but more precise, perfect for the dense woods where air signals might not travel far. And then there are cross-species conversations. Birches and firs, though different in kind, still exchange carbon and alerts underground. It is as though the forest hosts a multilingual community, where each tree has its own mother tongue, but also learns enough of others to share meaning. Scientists have even found that stress plants, sometimes emit high-pitched clicks that other species respond to. It is as though the cries of distress are understood across boundaries, uniting very different plants in mutual awareness. Stories also tell us of plants reaching out to animals. Some trees release scents not to warn their own kind, but to attract predators that will defend them. The sweet smell of a damaged corn plant, for instance, draws wasps that hunt caterpillars. The language here is cross-kingdom, a tree speaking to an insect, using chemistry as a bridge. And perhaps most astonishing of all, humans have been part of these conversations for centuries, though we rarely realize it. When we breathe in the calming scent of pine, or feel uplifted by the aroma of eucalyptus, we are, in a way, receiving messages that trees send into the air. To them, these molecules may be signals of defense or stress. To us, they become sensations of peace, of freshness, of clarity, different languages, different listeners, and yet communication flows. The forest is never silent. It is filled with tongues we cannot hear, dialects we cannot see, and meanings we are only beginning to translate. So, when you next walk among trees, imagine for a moment that you are standing in a hall of many voices, not in words we know, but in whispers of chemistry, in murmurs of electricity, in vibrations of thirst and need. 1,000 languages, 1,000 conversations, woven into the stillness of leaves. The forest is speaking, always speaking. The forest in spring is like a slow breath returning after a long slumber. Snow melts, streams begin to flow, and the air softens with warmth. Beneath the soil, roots awaken too. They begin exchanging sugars, water, and signals more actively. Mother trees stir from their winter rest, sending gentle pulses of nutrients to young saplings, helping them push up their first tender leaves. In this season, the conversations are bright and urgent. Trees release signals that say, "It is time, grow, stretch, awaken." Young buds break open, guided not just by sunlight and warmth, but by hormones and chemical cues moving through their tissues. Neighboring trees often synchronize their leaf out, so that entire groves flush with green together, a coordinated response to the season's call. Pollination, too, is guided by subtle conversations. Flowering trees release scents, not only to attract bees, but also to signal readiness to one another. It is as if spring is a grand symphony, with each tree adding its own note at just the right time, and the underground networks hum with activity. Carbohydrates stored from the previous year are shared with those in need. Fungal partners deliver phosphorus to eager roots, while receiving sugars in return. Everywhere in spring, the forest is whispering, "Wake up, it is time to live again." As spring ripens into summer, the forest reaches its height of energy. Leaves spread wide, drinking in sunlight, producing an abundance of sugars. The conversations now are steady, strong, and full of exchange. Trees in summer often share more carbon than they keep. Mother trees pass extra sugars underground, supporting shaded saplings. Signals about pests and pathogens flow constantly, alerting neighbors to be on guard. The air becomes thick with volatile compounds. Pines release sharp resins that deter insects. Maples release sweet aromas when their leaves are chewed. The very fragrance of a summer forest, that deep green, slightly sweet, slightly resinous smell, is part of its language. To us, it feels calming. To the forest, it is communication in full bloom, Animals, too, are woven into these summer conversations. Fruit trees ripen their berries and apples, not only feeding birds and mammals, but signaling, "It is time, carry my seeds." The bright colors of fruit are visual messages, designed to be read by eyes, just as chemical scents are meant for noses. And during drought, summer conversations can shift to urgency. Trees underwater stress click and pop with ultrasonic sounds, warning others of dry conditions. Some even adjust their leaf openings, their stomata, based on cues from neighbors. Summer is abundance, but also vigilance, a season of life at its peak, with voices rising in a chorus of activity. As days grow shorter, a change comes over the forest. Autumn begins. Now the messages turn from growth to preparation. Leaves begin to change color. But behind the beauty lies careful communication. Trees draw nutrients back from their leaves, storing them in roots and trunks. Signals pass through tissues, telling branches to harden, to prepare for frost. Even underground, fungal partners receive one last gift of sugars before the flow slows down. It is a season of generosity, a gentle farewell before the stillness of winter. Autumn conversations are also communal. Some trees shed leaves earlier than others, and the fallen litter nourishes the soil. Neighbors benefit from this gift, just as they benefited from summer's shared sugars. It is a language of letting go, of making space, of closing one chapter to prepare for the next. And then comes winter. The forest grows still, but it is not silent. Beneath the snow, roots continue slow exchanges. Mother trees still pass nutrients, though at a gentler pace. Electrical signals still travel, though muted by the cold. It is as if the forest whispers in sleep, breathing slowly, dreaming quietly, waiting for spring's call once more. Even in dormancy, trees sense. They feel the lengthening nights, the deepening frost, and when the first hints of warmth return, they are ready to awaken again. The cycle repeats, a conversation without end. Spring's awakening, summer's abundance, autumn's retreat, winter's rest. Each season a voice, each voice part of the forest song. And as we listen to this eternal rhythm, we may hear something for ourselves too, a reminder that life has its own cycles, its own seasons of growth, fullness, letting go, and rest. The forest teaches, always, not in words, but in rhythms, not in speeches, but in seasons. In the green hush of a summer forest, you might notice a caterpillar nibbling at a leaf. It seems so small, so harmless, but to the tree, this tiny visitor is a signal, a trigger for a whole cascade of responses. The moment the leaf is pierced, the tree releases volatile chemicals into the air. Some of these compounds warn nearby trees. Prepare your defenses. Danger is here. But others are meant for ears, or rather, for noses, far different from a tree's own kind. Wasps, for example, are drawn to these scents. They follow the invisible trail through the air, seeking the very caterpillars that feed on the leaves. When they arrive, they lay their eggs inside the caterpillars, and the young wasps consume them from within. The tree has not only defended itself, it has recruited allies. This is not rare. Corn plants under attack do the same. Tomatoes, too. The plant kingdom speaks to insects in chemical words, and insects, in turn, respond with precision. Even pollinators are guided by these conversations. The sweet fragrance of a blooming apple tree is more than beauty, it is a signal. Bees read it as a call. Come, gather nectar, carry my pollen, and when one flower is pollinated, the scent may change, telling pollinators to move along to others still waiting. To insects, a forest is not silent. It is filled with invitations, warnings, and guidance. And trees, though rooted and still, shape the very survival of countless tiny lives. If we lift our eyes higher, to the branches above, we find birds, songbirds, woodpeckers, owls, each one influenced by the subtle ways trees communicate. When a tree produces a heavy crop of acorns or seeds, this is not random. It is a massed year, a coordinated decision across many trees of the same kind. In mass years, animals like jays, squirrels, and deer find an abundance of food. Populations rise, nesting success increases, and migrations may shift. But in years that follow, trees produce fewer seeds, and animal numbers adjust again. This rhythm, set by the tree's collective choices, directly shapes the lives of animals across entire landscapes. Birds also respond to chemical signals. Some species, like the great tit in Europe, hunt caterpillars more effectively. When trees release certain distress scents, the scent acts almost like a map, guiding birds to branches where insects hide. The tree benefits from fewer pests. The bird benefits from an easy meal. Mammals, too, are part of these stories. Giraffes, as we learned earlier, move carefully between acacias, avoiding those that have been worn by neighbors. Deer shift their feeding based on tannin levels, which rise after trees share alerts. Even elephants, with their deep awareness, seem to recognize when a stand of trees is signaling stress. And let us not forget bats. Some trees release night-blooming scents that specifically attract bats, who feed on nectar and carry pollen across great distances. The conversation here unfolds under starlight, a dialogue between rooted trees and winged mammals, bridging two very different worlds. Beyond food and scent, the very structure of tree communication shapes entire animal communities. Mother trees, with their wide canopies, provide nesting grounds for birds. Their fallen logs shelter salamanders. Their bark houses beetles and ants. By supporting young saplings through underground networks, they ensure that diverse habitats continue to grow, which in turn supports diverse animal life. Even fallen leaves, guided by seasonal conversations, become homes for countless creatures. Insects burrow, spiders hide, frogs seek moisture beneath the damp layers. The animal's survival depends on these cycles, these messages that guide when trees let go of their leaves. Some of the most remarkable stories involve cross-species cooperation. Take the Clark's nutcracker, a bird of the American West. Each autumn, it gathers tens of thousands of pine seeds, burying them across the forest floor. Not all are eaten. Many sprout into new trees. The pine tree communicates its readiness to spread by producing rich, nourishing seeds, and the bird answers, becoming both messenger and planter. In Africa, fruiting trees draw in primates, who carry seeds in their stomachs and deposit them far away. In the Amazon, bats carry figs across the night sky, seeding forests anew. The dialogue here is not spoken, but it is deeply mutual. Trees provide nourishment. Animals provide movement. Together, they weave the endless cycle of renewal. When we look at this wider picture, we see that animal lives are not separate from tree communication. They're entwined with it. The warnings, the gifts, the cycles of abundance and retreat, all ripple outward, guiding migrations, diets, behaviors, and survival. The forest, in its quiet, becomes a living orchestra. The trees are the deep, steady instruments, their signals resonating through soil and air. The animals are the voices, responding, adjusting, thriving. And we, too, are listeners, though often unaware. The lesson is clear. Every songbird's nest, every squirrel's cache, every butterfly's flight path is shaped in part by the whispers of the trees. So next time you see a bird dart into a leafy canopy, or a deer pause to nibble a branch, remember, you are witnessing a conversation, one that began long before you arrived, and will continue long after you leave. Step into a forest, pause for a moment, look around at the trees. To the eye, it seems like many, oak and birch, pine and cedar, each standing alone, each with its own trunk, its own crown of leaves. But beneath the soil, a very different picture emerges. The root tips of one tree touch the roots of another. Threads of mycorrhizal fungi weave from one species to the next. Sugars flow, minerals trade hands, and electrical pulses pass like quiet whispers. The forest is a network, not a collection, but a unity. Scientists call this the wide web, but to stand within it, to sense the air, you might call it something softer, a heartbeat, a breath that rises and falls. When one tree struggles, others help. When one tree flourishes, it shares. No, being in the forest truly stands alone. Every root is a thread in the tapestry of the whole. It is a reminder that life is not separate parts, but a woven fabric, and we, who so often see only individuals, are invited to look deeper, to see the unity that hums quietly beneath. Imagine for a moment that the forest is a single organism. Its trees are like the organs, each with a role to play. The roots are like arteries and veins, carrying water and nutrients. The fungal networks are like nerves, sending signals across distance. The canopy is like skin, breathing in carbon dioxide, releasing oxygen back into the air. Even its seasons feel like a pulse. Spring is the inhale, leaves unfurling, sap rising. Summer is the steady heartbeat, full of growth and abundance. Autumn is the exhale, leaves falling, energy retreating to the roots. Winter is the stillness, the pause between breaths. And just as in a body, health depends on balance. If disease strikes one organ, the whole system feels the strain. If nutrients are short, the entire body slows. But when all parts work together, the forest thrives. Indigenous cultures have long spoken of this. To them, the forest was not resources to be taken, but kin, a living relative. Every bird's song, every stream's murmur, every tree's shade was part of the same being. Modern science, in its own language, is finding the same truth, that forests are cooperative, self-regulating, interdependent, that their unity is not metaphor, but measurable, visible in data, confirmed by experiment. To walk among the trunks, then, is like walking inside a living body, each breath you take, interwoven with the breath of the trees. Now, let us widen the circle. We are part of this unity too. Every breath we take fills with oxygen that trees release. Every exhale we give is carbon dioxide that trees require, a perfect exchange, a conversation older than humanity itself. When we burn wood for warmth or build homes from timber, the forest shelters us. When we wander its paths, listening to bird song, breathing the earthy scent of moss, the forest heals us, and we in turn hold power over its fate. We can cut too quickly, burn too fiercely, and break the bonds that hold it together. Or we can nurture, protect, and allow the ancient unity to endure. When we care for forests, we are not caring for others. We are caring for part of ourselves. For without forests, the air would thin, the waters would dry, the climate would lose balance, the great body of the earth would weaken. But when we let forests live, they remind us what wholeness looks like. They show us a community where nothing stands alone, where strength is found in sharing, and survival is written in cooperation. So tonight, as you close your eyes, imagine yourself not as separate, but as part of this greater unity. A leaf upon a branch, a root in the soil, a note in the forest's vast and gentle song. The trees speak to one another. The animals answer. The streams carry the echoes. And you are part of that conversation too. And with that, dear listener, we softly reach the end of our journey. We began with silence, with the mystery of trees whispering through roots and fungi. We wandered through warning signals. Mother trees, the languages of scent and season, and the ways animals join in the chorus. And now we see it whole, a forest not as many, but as one. May this understanding bring you peace. May it soothe your mind and soften your dreams. Good night, gentle soul. Goodbye for now, and may the forest sing to you, even in your sleep.